Our next question deals with a function machine. And you can see you have an input, you add 3 to it, then you multiply by 5 to generate your output. A number is input into the machine and the output is 21. Work out the number that was input into the machine. What I'm going to say is let's call my input x. I'm going to add 3 to it, and then I'm going to multiply the whole thing by 5. And when I do that, my output is 21. I'm going to expand my brackets. 5x add 15 equals 21. Subtract 15, 5x equals 6. Divide by 5, x is 6 over 5, which is equal to 1.2. A number is input into the machine. The output is 3 times the input. Work out the number that was input into the machine. So I'm going to do the same thing again. I'm going to say, well, I put x in, so I get 5 brackets x add 3, just like before. Add 3 to it, multiply by 5. And now that is equal to 3 times the input, so 3 lots of x. I expand again. 5x add 15 is equal to 3x. I subtract 3x, 2x, and I also subtract 15. 2x is negative 15. I divide by 2x is negative 7.5, and that is my final answer. Part C, a whole number is input into the machine. The output is then used as a new input to produce a second output. Rosa says the last digit of the second output must be a 5. Is she correct? Well, one thing I could do here is just try some numbers and see if any of them contradict her. But let's take a more systematic approach. Let's say, okay, well, I put a number in, I add 3 to it, I get another number, and I multiply it by 5. Well, if I multiply any integer by 5, I'm going to get a number that either ends in a 0 or a 5. Then I put that back into my machine, I add 3 to it, so now my number's going to end in 3 or 8, and I multiply it by 5. Well, when I multiply by 5, 8 times 5 is 40, so I end in a 0. 3 times 5 is 15, I end in a 5. Rosa said it will always be a 5, so we know that is not true. Now, I could try to explain that in here, but for 1 mark, I'm just going to give a counter example. But I know that she is not correct, so no, she is not correct. And my reason, I'm going to look for a counter example. I want a number that, when adding 3 to it and multiplying by 5, gives me a number ending in 5, because that's what ends up in this situation. So, anything multiplied by 5, if it's an even number, will end in 0, an odd number will end in 5. So I want a number, when 3 is added to it, giving me an odd number. Let's say if my input is 2, because then when I add 3 to it, I get 5 multiplied by 5, my output is 25, and then I put that as my input, because we're going through the machine twice. I add 3 to it, that's 28, and then 28 multiplied by 5 is 140. So she is incorrect, and I've given a counter example, and hopefully that's a slightly better way to think about this. Question 5. A primary school has 240 pupils. 90 of these pupils have no siblings. A nearby secondary school has 960 pupils. Use this information to estimate how many have no siblings in the secondary school. So what we're going to do is assume the proportions without siblings are the same. So in the primary school, 90 out of 240, that is 90 out of 240, 3/8 have no siblings. And so then in the secondary, we want to know what 3/8 of the total students is. 3/8 of 960, so I multiply by 960. There are 360 students we estimate that will not have any siblings. Is your answer to part A likely to be an overestimate or an underestimate? Explain why. So I'm looking for differences between the primary school, where I got my proportion from, and the secondary school, which I've gone on to estimate. Now, there are 2 key differences here. One is the secondary school has more pupils. I don't really think that's going to have a direct effect on the proportion of siblings, so I discard that for now. The other is that secondary school students are older. If secondary school students are older, their parents are more likely to have had more children. They're more likely to have siblings. So, secondary school students are older, and therefore they are more likely to have siblings, or alternatively, less likely to have no siblings. And that's what we're working with here. How many have no siblings? So therefore they are less likely to have no siblings. So if we look at our calculation here, if they're less likely to have no siblings, that 3/8 will go down, so our final answer will go down. So this implies that our answer here is an overestimate, because in reality we're expecting the value to be slightly lower, because some of these 360, when they're at primary school, by the time they've reached secondary school, they will have had a sibling arrive. So it's an overestimate of our results. And that's our next couple of marks sorted.